Hello, everyone. Ladies and gentlemen, we extend a very warm welcome to today's highly anticipated webinar on large language models and data visualization, enhancing product engineering insights. I'm Anisha, and on behalf of entire team at Walking Tree, I extend a warm welcome to all of you. It's a pleasure to have all of you with us today. So before we dive into today's agenda, let's take a moment to greet everyone who is still joining us. And for those who are not familiar with Walking Tree, let me provide a brief introduction. Walking Tree takes immense pride in our unceasing commitment to technology-driven innovation. Our expertise lies in conceptualizing and executing cutting-edge web and mobile applications across various platforms. We are more than just a company. We are a collective of forward thinkers dedicated to seamless system integration and propelling digital transformation initiatives. Our core strength revolves around advanced data integration, analytics, and the modernization of legacy systems onto high-performance platforms. We offer a comprehensive suite of business intelligence solutions tailored to diverse domains, thus empowering businesses with enhanced agility and efficiency. So, for today's session, we will unravel the pivotal role of data visualization in the sphere of product engineering. We will explore techniques for harnessing the power of large language models with relational databases, thus unlocking the potential of text-to-SQL. Moreover, we will delve into the art of text-to-dashboard, illuminating how large language models can supercharge our data analysis, making it more intuitive and insightful. I'm particularly excited about this segment because this segment has the potential to transform the way that we approach in our data-driven decision making. And to top it all off, we'll present a compelling case study showcasing the impact of interactive dashboards on user experience. This real-world example will illustrate how the insights that you will gain during this webinar can be practically applied to enhance user satisfaction and engagement. At the end of this webinar, we'll allocate some time for addressing all your questions and insights. And I encourage all of you to submit your queries in the Q&A box throughout the session. So let's harness this collective intelligence of our audience today to foster an enriching and interactive discussion. I would also like to let you all know that we will also be sharing a recording. So if you have to step away from your screens or if you miss any part of the webinar, we'll be sharing a recording. Without much further ado, I will introduce our esteemed speakers for today's session. So we have Scott Seabolt, CTO from Walking Tree Technologies, and Abhilasha Sinha, our Chief Solutions Architect, with us today. Scott brings with him over 30 years of experience as an astute problem solver. He's an entrepreneur and a tech leader as well. He has been instrumental in driving our organization's digital and data analytics capabilities, thus fostering a culture of client-centric innovation. His invaluable guidance and insights have empowered both our clients and our Walking Tree team as well to navigate challenges, seize opportunities, and foster innovative growth. His palpable passion for the transformative potential of generative AI is truly inspiring, and we are thrilled to have him today leading our team towards new horizons. Abhilasha boasts an illustrious career spanning 2 decades, during which she has led high-performing teams in developing enterprise-scale products and applications. And with a decade of experience in driving end-to-end design and development of complex analytic solutions across diverse industry segments, she has earned a reputation as a seasoned leader in the field. A contagious excitement for the transformative potential of generative AI further enhances our exploration of new frontiers. Now I'll hand it over to Scott to take us further from here. How are you doing, Scott, today?
Hey, Anisha, doing great. Thank you very much. Thanks for the intro. So doing good. Excited to share today. All right, guys. So thanks again. Thank you for joining us. As Anisha mentioned, I'm Scott Seabolt, the CTO for Walking Tree. So I get the pleasure of working with a lot of the new technologies that come our way and kind of develop a roadmap for us as a services company and kind of how we go forward and what we focus on from a technology standpoint. So today, like a lot of things, we've been kind of, for lack of a better word, we've been playing in this space for quite some time. And what we typically do is try to share at some point, our excitement after we've kind of gotten our arms around things just a little bit. We try to share with you. So, and this one's no different. So, today I'm going to open up a little bit and start to begin with anyway, talk about, what data visualization means, right? What is it and how does it enhance your product engineering insights, right? And how does it kind of relate along those lines? So with that, just to quickly go through the agenda, just to give you an idea of kind of where we're going. We'll start out, like I said, with me talking about the significance of visualization and data visualization in product engineering. And then Abhilasha will take us most of the rest of the way with this in terms of talking about text-to-SQL and really the techniques of using large language models with our maybe existing relational databases, for example. And then she'll talk about what it means to go from not just text to SQL, but text to dashboarding and providing, enhancing insights with the power of LLMs. And then lastly, we'll share an interactive visualization and a user experience with you. So that's kind of where we're going. Hopefully that meets your expectations. It's, as they say, when you get on the plane. If you're on the wrong plane, might be a good time to leave, but hopefully you'll stay with us. So let's kind of dive into, just to open up, what is the significance of data visualization in product engineering? So just kind of the basics of, what does this do for us in terms of product engineering? And I would say just in general to open up, is what's the importance of data visualization even? So these are not new concepts that I'll kind of go through, but let's just talk about these. And as we think about how this relates to even using, say, a generative AI or a large language model to help this area, it'll kind of set the context for us. Okay, so data visualization is it's a crucial tool, right, for understanding and really communicating really complex information really in a more accessible and a more accessible and really intuitive way, right? So kind of goes back to the old a picture's worth 1,000 words kind of thing. And, with visualization, that's the goal, is to try to give you an accessible and intuitive way to look at a complex set of data. And, let's just kind of go through, some of the key reasons that we highlight the importance of visualization. And that first one is, it enhances our understanding. So data visualization, it translates raw data into visual formats like, charts and graphs and maps. And the goal to make it easier, right, to grasp for people to grasp patterns or trends or see insights that may be kind of hidden in the numbers or might not be so intuitive just looking at the numbers themselves. And then data visualization helps facilitate decision making, right? So when we talk about visualization, in terms of in terms of decision making, and I'm just trying to think in my world what that means, right, is a different thing in terms of what a CTO looks at, and then a CEO of a company might look at another thing, or maybe even an analyst or a specialist in a company. So it helps us all, and even in different roles, make decisions. So visualization really helps the user make a more informed decision, because they can look at the data and kind of visualize it in a way they couldn't just by looking at the numbers. So it provides, ideally, right, provides a clear representation of the data, and it enables them to identify opportunities and maybe even risks that they might not see just by looking at raw data. So it helps with decision making. It also helps identify trends and patterns. So through visualization analysis, visual analysis, trends and correlations, anomalies, they become more apparent in a visual analysis and a visual look. So if you can look at a chart or a map or something of that nature, it's sometimes easier to see those things that you couldn't normally see. So it helps people like researchers and analysts identify those patterns that might not be so evident in like a tabular form. Like if you're looking at a spreadsheet with a bunch of tabs, it might not be so clear to help to be able to identify those trends and so forth. And then it's an effective communication tool, right? So visuals can convey really complex ideas quickly and effectively, right? Without having to go through all that data and comb through and trying to process it all. Visualization can kind of quickly and effectively help you communicate those ideas. And then, memorability. And I know for me, for example, I'm a very visual person. So when I see things, and being an technical architect in the past, I like diagrams. I looking at things and visualizing what systems look like. And what that does for me, it helps me kind of memorize or remember what the system is like, or maybe it's the business or whatever it might be. So again, a picture's worth 1,000 words, and it kind of sticks with you. That visual sticks with you, so it's more memorable. And then you can detect outliers. So what might not be so apparent with a bunch of data, right? With visualization, you can easily see what those outliers might be. So you can spot the outliers, irregularities, and those can really become critical for you in terms of quality control and anomaly detection of those things. And maybe it's finance, maybe it's healthcare, whatever the case might be, right? And it improves storytelling too. So visualizations, they can be used to tell a compelling data-driven story, and that can integrate into reports and presentations. They make the narrative really more engaging and persuasive. And then interactive exploration. It's great to be able to just click on something and be able to dive into that data, right? So you can more easily explore that data when you've got those visual elements. So it allows you to better deep dive into what that data is saying, even in those minute areas. So the other thing is validation, data validation. Visualization helps validate data quality and integrity. So when data is presented visually, errors and inconsistencies are more likely to stand out to you. And then lastly, with this slide, in terms of cross-disciplinary insights, data visualization really translates even language barriers, right? It makes it really an invaluable tool for sharing insights across different fields or different cultures. I've traveled a lot in my past, doing a lot of backpacking in remote areas. And even though I didn't know the language in those areas, I found a lot of times what the best way for me to pick up on some of that language is to work with the children there, and they would draw circles in the sand a lot of times, or draw with chalk or something. And they would draw and then say the word, and it helped me even recognize the language, right? So it's kind of cross-disciplinary, even across different fields and different cultures. Those visuals help us communicate those things. So I would say in summary, data visualization, it plays a vital role in really simplifying complex data. It aids in our decision-making, and it improves our communication. And it's really an essential tool, I think, for professionals across various domains. And those could include business, science, healthcare, public policy, and really visualization really helps us, I'd say, unlock the full potential of our data. Well, how about, in terms of product engineering, right? And that could mean, for me, a lot of times that means a software product, right? But it can also mean actual physical product as well. So it could be manufacturing, could be healthcare, could be any type of outcome or any type of product that you're trying to develop and explore. And just around that, some of these things will be similar. So I won't, as a previous slide, but just to kind of give you an idea, let's quickly walk through these. Again, in terms of product engineering, the importance of visualization is decision-making, right? So, and in terms of product engineering, it helps product engineers and teams really make data-driven decisions. And again, without having to comb through tons of data, you can have the visualization and quickly help you to see, hey, what impact is my product going to have here? Or maybe you're doing proof of concepts and that type thing. So it really helps us in terms of being able to make decisions about our product engineering. And then, like I said, designing and prototypes can even help us prototype what the product might do for us. So it helps us visualize what the outcome could be. Performance monitoring is another thing, right? Data visualization tools allows engineers to monitor the performance of products and systems in real time. So you can see it, you have a really good idea maybe in real time of what's going on. You can actually see it. And that could be in terms of things like IoT devices, for example, or systems where, continuous monitoring is really essential. Quality control is another area. Engineers can use data visualization to track quality metrics and identify defects in areas. I know for us in software, that's especially true with tools, with various quality control tools, to be able to see, or okay, did tests fail or pass, or is there quality issues, security issues, those kind of things. So quality control is another area. Customer feedback, again, visualization is a great way to look at customer feedback and really kind of get the sentiment of what those customers' preferences are, or their dissatisfaction even of what's going on with a certain product. Supply chain optimization is another one. So optimizing supply chain by tracking inventory levels, maybe transportation routes, production schedules, and really to make sure you're efficiently providing delivery of either supplies to produce your product or even delivery of your own product. Resource allocation is another one that's important to companies like Walking Tree, because product engineering teams, you can allocate those resources more effectively by visualizing the data and looking at timelines for projects and the actual runs and the budgets and how resources are being utilized. And then risk assessment's another one. Again, being able to look at your product designs and looking at what risks might get introduced or what's out there, right? And then to wrap this one up, market analysis, probably don't need a lot of explanation there, but looking at marketing trends, competitive performance or consumer behavior, for example, those all aid in the development of products that meet market demand. So, and the last one here, communication. Again, we've kind of talked about this one, but visual really helps you communicate. And I would say an area that's helpful for me as a technical resource is to really to communicate a complex technical idea or information to non-technical stakeholders. So maybe executives, investors, or users themselves, right? So those are kind of some things around what it means in terms of product engineering. And the next thing I want to kind of introduce, and maybe you've already been introduced to this, was just the concept of really, this whole idea of self-service business intelligence, right? And we kind of got a couple of quotes here on how do we define that, right? So Gartner's definition is self-service business intelligence is defined as end users, as end users designing and deploying their own reports and analysis within an approved and supported architecture and tools portfolio. Or, take Target's definition was self-service BI is an approach to data analytics that enables business users to access and explore data sets, even if they don't have a background in BI or related function like data mining or statistical analysis. So, in other words, this concept of self-service BI is where, your actual business folks, your business users can actually self-service themselves and get that data and visualize that data without a lot of help from the more technical side and technical folks. Now, as we talk about this, and in terms of self-service and where that's at, right, is Are these at 100%? Is this going to do away with the need for those folks? I would say absolutely not, but it is a good enhancement and a good way for us to get good data. And this will improve over time as well. So we'll talk about that in terms of things like comprehensive, being comprehensive and even the accuracy too, right? All right, let's see. Yeah, here we go. So the next area that we'll look at is really around self-service analytics and talk about how is that accomplished, right? And then specifically, let's look at two layers. Let's look at the large language model, and then let's look at the semantic layer. So if we look at that in terms of layers, we got the LLM and we've got the semantic layer. And the way those are divided out, the large language model, right? Those are really powerful and they can understand the intent of the user and they can generate responses in the required format. And for instance, the next topic we're going to hit is on text-to-SQL and text-to-dashboard. So they're able to really look at a lot of that information and comprehend what that information is. Now, again, is that out of the box 100%? No, and I think Abhilasha will kind of mention some of this as well. But it really is I've learned with large language models, every time I'm a bit skeptical about, well, can it really do this? Can it really do that? Usually exceeds my expectations. So I'm a born skeptic and I'm always that way. But I think what we found even in this area is that we get some pretty good percentages on the accuracy and the comprehension of the large language models. And to help that along, right, when you look at the Venn diagram over on the right-hand side, kind of that cross-sectional, kind of the large language model, the semantic layer, large language models are good for comprehension. The semantic layer is good for correctness and helping to try to ensure correctness. And in the case of text-to-SQL, to try to look at the accuracy of those generated queries, right? And then in the middle of that, the intersection is, our context there. So the combination of these two really is a powerful the combination of power and understanding of the LLMs really enriched by the control and the correctness of the semantic layer can generate great results for us in terms of coming up with a self-service or interactive analysis. So again, is all this 100% out of the box? No, I would definitely say no, but we're seeing good progress there. And really it's helping aid in ensuring that just your business type person can create or have a self-service analytics platform they can work with, right? So, and we'll talk about that again more. I think what we've noticed even with from my perspective, from a CTO, looking at my developers and providing tools for them to work with, are we seeing 100% if a developer goes in and tries to use generative AI to say, I want to come up with this code? Is it 100%? No. But even if I'm seeing numbers, that are 30, 40, 50%, right, and that continues to grow, that's still really good progress and a really good tool for us. So keep those in mind. I know that question's probably going to come up as, well, what about the correctness of these? What about things like, hallucination and all those kind of things? So, but as we continue to train these technologies and come up with better techniques for like prompting and so forth, they get better and better. So I've learned to keep my skepticism in place, but also come to the realization that, boy, things are really moving well in that direction and we're getting good results. So just to, and I'll almost finish with my area here, the advantages of a self-service, right? Ideally, in an ideal world, the advantages are, hey, we get quick and precise answers without assistance. We have the ability to access and explore data on our own, even as business folks, without having a degree in data science, for example. No dependency on technology and technical skills in that case, and making it available as a response to really textual input, right, in natural language. So ideally, those really are the advantages. Now, again, the reality is, that we may have to work with that to get them trained, to make them more accurate. but that is the concept, right? And I think there's good progress there for sure. And just real quickly, when we talk text to analysis, analytics use cases, what are they? Generating queries that can be run on natural language questions, chatbots that can answer questions, based on database data in the form of like charts and other visuals. So the text to SQL, that's really where that comes into play. And then building custom dashboards based on insights a user wants to analyze. And then lastly, being able to ask direct questions about your data sitting in a database or a data warehouse, and to really get live analytics. And with that, I am going to go turn this over to our data lead, our AI lead here at Walking Tree, and that's Abhilasha. So Abhilasha, with that, I'm going to turn it over to you. I think. There we go.
Yeah, thank you, Scott. I hope my screen is visible.
It is.
Okay, so with that introduction on the need for data visualization and how with the power of large language models and with the control of the semantic layer, we can bring in visualization to a normal user just by the like a normal text query. So that is what we are targeting, and to achieve that, like the semantic layer is what becomes important and how we are actually implementing that to make the best use of the LLM. So when we talk about text to SQL or text to dashboard, at the bottom of it, there is always the LLM. But on top of it, how you're using the LLM, that is what becomes important. And that is what we are going to see today. So definitely, like all the enterprise data is sitting in either like the structured data, maybe the SQL databases, data warehouses. And as a regular user, like if I have to get into the details of my data, I really have to depend on like have a technical, maybe a solution around maybe a Power BI or go for a custom dashboard. And then again, that would give me some flexibility. But then if I want something impromptu, so that is what we are trying to achieve here. And making the enterprise data available at like just at a query. Now, to achieve this, we have the capability of LLMs. So we have like traditionally there have been other models, and this is an old problem like text to SQL, which people have been trying to solve, and they have got reasonable accuracy there. And with the power of LLM, it has improved. Now, with generative AI becoming so popular and frameworks like LangChain and Llama Index coming in and bringing the entire ecosystem to support any kind of development around LLMs. So definitely around text to SQL also, LangChain provides the ecosystem of chains and agents which are specifically dedicated for SQL, which cater to the functionality of building, like generating SQL queries. So we look at that. Llama Index again. Llama Index brings in the more augmented capabilities, which like allow us to connect to different kinds of databases or data sources rather. And SQL tables and data warehouses is another flavor there. So definitely Llama Index brings its own ecosystem of supporting the text to SQL capability. So with this ecosystem, the tools are mostly like they are supported by the SQL dialect, which we are talking about here. Of course, this can be extended to a NoSQL or a GraphQL, and there are capabilities in these systems to be able to connect to those and get data from there as well. But today's focus is more on the SQL dialect, and that's where that is supported by SQL Alchemy. So that provides us the drivers or the tools to connect to these data sources and be able to run our generate our queries and then run our queries. So when we start with, or when we talk about LangChain, so LangChain has like a rich ecosystem, we all know, and that it has dedicated chains for SQL queries. So the idea or how it works is when the user gives a natural language question, it is passed to the LLM with the additional context. It generates the query, and then the query could be executed on the database directly, and the answer could be derived. So that second part you see is optional because depending on the need, you would want to integrate the tool. So if you're using an agent will facilitate you to connect to the database tools as well. So you can have a database engine attached as one of your tools, wherein once you get your query, you can execute your query and get the results and format your result using LLMs to get a proper answer. So that could be optional in some scenarios, and we'll talk about it as we move on. So this is the scenario which we're talking about, where the question goes in, the validation, the LLM works. So this LLM chain which you see here and this dotted part is an optional part, but then that's what the hallucination and the incorrectness which Scott mentioned. So that is the control you can bring in with the validation and the improvement cycle. So you can have a feedback cycle, and for that again you have different tools provided by this ecosystem which can enable you to go into a feedback and ensure that your final query is correct, and then it runs on the database, and then you generate a response back to the user. So if it's a very simple query, obviously you just give the prompt and the LLM will generate. But definitely in an enterprise scenario, that will not be the case. There will be a complicated database schema, and you will have to give specific instructions. So that is where usually it starts off with giving either you give the create table description of the table, wherein it has the table names and the column types, or you can give it in a format where you cover these details. And of course, if there is a relationship involved between multiple tables, you would give those details also. Also, when if you're trying to say cater to a specific need and you think that it is a complicated query, you can also provide some examples as part of your few shot learning, and that could enable the LLM to pick up the right column names, because mostly one common issue which we see is the LLM will come up with their own column names in spite of giving the schema. Sometimes they are not able to detect the right column to pick, because of it could be because of the uniqueness of your domain. So that is where you need to provide that additional context, additional examples to improve the correctness of your query. So similarly, if you're using Llama Index, so again, the overall approach remains the same. It's just that Llama Index gives you some more structured tools which give this additional capability and control of the environment to generate the query. So suppose there could be scenarios like if you want to give your complete schema, or if you want to exclude some tables when you're trying to generate, because obviously you would want to control the prompt size, right? The token size. So you would only want to give the required table. So again, that is one level of control you can bring. Then you could incorporate additional context where you have to include certain additional instructions for the prompt to use specific columns or tables for the purpose of for the understanding of some specific column. So that if you think of this is all actually the semantic layer which you're adding, the extra context, the extra understanding to the LLM, using which it is able to generate. So if you just ask the LLM to generate, it will still generate and give you a query. But obviously that is not as per your schema and as per your context. And that is the layer you are adding with the means of these different instructions. So as part of Llama Index, some of the useful tools which I can mention here. So NLSQL table query engine, which allows you to connect to the tables, the schema, and execute the queries and give you the results. So the synthesis of the response, and you get a proper response. The SQL table retriever query engine. So this, the second one here, this actually brings in the extra flavor of if you have like a very huge schema and you really don't want to pass the whole schema, which will be a real use case in any enterprise. You would not want to pass the entire schema to your database, but you would not want to like have to give the instruction every time that, okay, for if this is the query, then use these tables. Or so for that, you can actually have like a another layer of query index, which will first query table index, which will first query the relevant tables for your schema, from your schema, which are needed to generate your query. And then that context will get passed on to the actual query engine to generate the response. So that is like additional level of filtering you can add. And SQL join query engine. This is a kind of query engine where you can actually append your structured data query with unstructured or like a vector database. And when your response has to come from multiple sources. So you query something from your database, and then you want to get more information about that from your vector database. So you join these two information and then pass it as a result. So a much more like a detailed response. So with this, like with these things in place, like what are the other things we can use to improve the accuracy of our generated queries? So as we saw, like the Llama Index provided query engines. And then, of course, you can add sample rows as examples. You can specify custom table information. So that's what, like, as I mentioned already, like specific tables can have specific instructions. So you can add that additional information as part of your instruction. Then you have other structures as part of, so here I've taken an example of the SQL database chain from the LangChain ecosystem, which gives you additional parameters when you're using that whether you want to say use a query checker. So basically query checker is an additional step in the chain, which will actually check whether your query is syntactically correct. And if not, then it goes into a retry loop, sorry, and gives you the like correct query response. Also, like if you have a requirement, like you want to dynamically insert some custom prompt, like a specific instruction, like for, as I mentioned, for the specific table. So again, in this ecosystem, you can use custom prompt, which can be inserted as a instruction. Also, if you want to have like a more interactive kind of generation, where you want to take the feedback from the user and you want to see the intermediate steps, you can also set the return intermediate steps as true. So that will give you a view of how your query is getting generated and maybe where it is going wrong. So, so that is the kind of extra improvements you can perform in the Text-to-SQL to get better quality results. Also, there is this SQL database toolkit agent. So this is the chain, and this is the agent as part of the LangChain, which actually gives you the capability to recover from errors. So again, you can see a different flavor. Basically, depending on the need and the scenario, you would pick up what flavor of implementation you would want to go for. So with an agent, you would have the capability to again check and recover from errors. So you get into caching the trace back, and if you're familiar with Langsmith, you can actually see the complete chain of how your query got generated and what went wrong, and then you can control it further. Also, there is a concept of auto-gen agents, which is very interesting. Like I came across recently, where you can have like multiple agents. So it's like you have 2 or 3 agents which are interacting with each other, conversing with each other, and then giving each other feedback and improving the response. So again, this is something which we can use to improve the correctness of our SQL queries and the final end result. So this is one example I included, which is like a type of prompt. So when we hear about prompt engineering, so there are different formats how you can control, and reason and act is one. React. So this is an example how the query will be formed, the different thoughts and actions the model will take. So this is an example of that. Also, like we tried this another example where, because a relational database is one flavor, but then many times you have your data warehouse where your data is centralized and you would want to run your queries on that. So with this ecosystem, so Llama Index there's a workaround with SQL Alchemy, which enables you to connect to Snowflake and generate your responses. So this is an example showing that. Then another, the one I spoke about, right, the auto-gen agent. So this is actually showing that. So you have a user proxy agent, you have an assistant agent, and basically the assistant will generate the code, and the user proxy will actually give the critique, the feedback, and they can interact. So this is a conversation. So basically, when you run this, you will see the conversation, how it is getting generated, and finally, obviously, your result quality and correctness will improve. So in this conversation, you can see like it's trying to plot a stock price chart to see the change, and then it will execute the code, and it finds that the package is missing. So again, okay, it will install the package, and then it will generate the chart, but then it says, okay, no, I was looking for a percentage. So it again goes for the revised, so code is revised, and using the matplotlib, it generates the revised chart here. So that is the kind of like interaction which happens. Like, so again, you can add a human in the loop also here, but it can be a proxy agent also. So you can avoid the human and you can make it automated and improve the correctness of your final result. Also, in many scenarios, we see that the customers do not want to use OpenAI models due to like data constraints. They don't want to expose their data, or they have some inhibitions and apprehensions about that. So there are open source models available for this purpose, which can be used. So some of these I've listed here. So Alpaca is a popular one. Falcon 7B and NSQ, so number station text-to-SQL. So this comes in again different parameter flavors, and like you have a minimum one also, which gives reasonable results for SQL. So if you want to like try for a smaller scale and you want to do it on-prem, you can go for these models, which allow you to like go for a commercial implementation, the NSQL. Moving on, so text-to-SQL is one flavor to it, but obviously there will be scenarios where you may not want to expose or give your database directly, make it accessible directly, and that is where you would have the API layer. So you could actually use the LLM to convert it into an API call, which will make a call to the API, get the response, and then you use the LLM to formulate the answer. So that is another flavor of, you can say, the semantic layer, where you are making the use of LLM, you are making the use of APIs, you're taking the text input and converting it into the API. So so this could be done in two ways. You either give your API specifications so that the LLM is able to decide, like in this scenario, this is the API I need to call, or you could make use of these GPT-4 function calling, where you can give the format of the call as an example in the function, and then the LLM will be able to generate the function calls. So the API call is generated, then you can make your call, get the response. So with this, the next flavor is the text to dashboard. And it is essentially a combination of the API and the SQL, because the API and the SQL is actually at the bottom layer, which will help you build the dashboard. So dashboard is nothing but putting together the different components. So with text to SQL and text to API, you would actually generate the charts, and then you would actually put them all together into your dashboard. So if you talk about a text to dashboard approach, it would start with understanding the input. So, I mean, obviously, if it's a dashboard, you would want multiple charts, right? Or it could be a single chart also. So you give your request to the model. The model will first understand and process, like, what are the charts which are needed, list it out in a structured format, and then decide, or maybe you don't mention what chart, you just give your business problem, and then the model decides which is the most suitable chart for this business problem. And then accordingly, that would be the first step, deciding on the chart, what type of chart would be needed. Then the next step would be getting the data. So this is where your text to SQL, text to API will come into picture, where you would use your natural language and generate the required query or API call to get your data. Once you have the data, once you have the configuration, you would put together the chart generation and then consolidate your dashboard. Again, the generation part of it, you can keep it flexible. So the chart generation layer could actually be a combination of, say, you can make use of LLMs here, or you can have a custom logic to build your charting libraries based on some reusable logic. So, I mean, that would depend on how much you want to make use of LLM and how much you want to have a complete control, because some part of it is definitely, you can say, more predictable, where you can actually make use of your custom logic and generate the code. So with that in place, when you're actually going for text to dashboard and when you have to generate your charts, so how would you generate your chart? So you got the data from your text to SQL and text to API. You would, how do you want to present the data? So you can make use of charting libraries. You have your JS libraries, your Python libraries, which you can use, and you can generate the code using your large language models or using your reusable code. You can have, sometimes you can also use dashboard specific APIs. So you already have your dashboards predefined, and making use of LLM, you're just trying to point to the right dashboard. And you can have your dashboard specific APIs, so like your Power BI APIs or your Apache Superset APIs, which will directly give you the response in the form of dashboard, which you can embed in your application. So just to make the API call, you can make use of your LLM to decide which dashboard to pick. So that could be another approach when you are trying to build this kind of application. Also, now, as part of the ecosystem, you can have like a predefined library of charts, and you like try to build your dashboard on the fly by plugging and playing with these library of charts. So that is another approach to go with the text to dashboard, where you are trying to understand your natural language request, and you're mapping it to your chart library, picking the right charts, and then building your dashboard. And finally, you can as well totally depend on your LLM and ask LLM to generate the technology specific code. So you can ask, I have to generate, say, a pie chart in Flutter, so give me the code. And in fact, that could be another way of looking at it. So with this, and when you're using your data and you're trying to combine or augment your LLM with the data, you have to be cautious about a few things. And that is where, like, these are some things which we need to remember. Definitely, you have to ensure that you're not exposing your database for database manipulation. So generally, you would give a view-only user access to your to your ecosystem when you're trying to generate or get the schema and generate the query or run the query. You can also add guardrails to ensure that the queries which are coming are only for select. There is no manipulation happening, like no create, insert, delete. Also, if you have any personally identifiable data which is sensitive, so you have to make sure you're not sending that data to LLM for your formatting. So then in those scenarios, you would rather do the formatting at your end and not use a public LLM. Also, for those cases, you would definitely do some kind of anonymization to save that data in an anonymized format so it is not exposed. So those kind of thought process has to go in when you are dealing with an enterprise sensitive data. Also, you should have a control on what data you want to pass to LLM. So it is only the data, only the database schema definition which you're passing, and maybe not the data, because the customer does not want to share the data or send the data on the public network. So definitely you would not want to do that. So in those scenarios, you would just format the code with your custom logic and present it in the results. Also, as part of this, you have to make sure that you're making use of this rich ecosystem to ensure that the queries which are generated are error-free and you are able to generate proper experience. In case, of course, I mean, you cannot guarantee 100% because there is a black box if you're using an LLM. So you should have a proper error handling mechanism, maybe a user-friendly message to asking the user to retry, or an extra layer of feedback or extra layer of check to, in spite of all this, to ensure that it goes into a further retry loop. So this will ensure a overall good experience, because after all, experience is what we are targeting here, because it is for the end user who wants a quick analytic view of the data. So with that, moving on to the last topic here, so I'll quickly show some of the examples and experiences on the use of interactive visualization. So this is one example which I really like, and if you are a cricket follower, then you would surely be aware of ESPN, and so I'll just move on to that. So this is basically a real example of text-to-SQL, which I just wanted to showcase the kind of experience this brings in. So this actually enables you to write a natural language query, and then gives you, so it refers to Stats Guru database and gives you a really good formatted response. So that is how you can make use of the large language model and bring in a final layer to give in the correct response in a presentable format. So so with the World Cup in news now today, it's starting. So I think the more trending queries are related to that, I think. But then, yeah, so you can see, yeah. So so this is a very general question, like best economy rate in a specific area with a cutoff of some over. So you can see a very specific query, but the model is able to fetch. So this is the power of the text-to-SQL. And maybe I can just show a few more examples here. Just bear with me. I'm not able to. Yeah, okay, sorry. So yeah, so I had a few examples just to give you a view of the things which we have been talking about. So this is the this is using a demo Postgres SQL server, and using, so this is another new, in fact now it is no more new, so many things happening in this ecosystem that like you get to hear new things every day. But LangChain expression language is another way of using the chain, basically a more user friendly way. So here you can see this is a way where you're giving the table info, you're giving the question as an input, you're giving some examples, and you're giving a dialect, a methodology of how, or some set of instructions. And then all this is passed to your SQL chain in the form of this pipe separated input to the parser. And the parser is ready to take any questions now. So then you invoke the chain with the question, and then you get a response. So you can see that this is the query which is getting generated. So this is only the chain. So that's why you're not seeing the results. You're only seeing the query. Now, this is another flavor of it, using the NLSQL table query engine, where you're, so here you would give the question, the response, and the final generated query. So again, you can see like here in this case, since you're using the NLSQL query engine, so it is actually executing the results. It is showing you, and then it is giving you the answer. It's also showing the query which you used to generate this. So similarly, like this is another example where you're trying to get the list of journalists along with the number of articles. So it is kind of join query with two different tables. So you can see here. Then another example which I can show here. So this is the AutoGen one which I mentioned. So here you can, I just wanted to show you. So the code is fine. The idea is, so you can see here, like this is the kind of log you will see when you execute this. It is the interaction. So this is the code which gets generated using Python and Matplotlib. This code got generated, and then it got passed to the executor agent, and then it gives you a critique, like the list of issues which it found with the code. So, and what you need to do with the code. So this is a immensely useful functionality. So you can see like it tried to execute and it failed, and that's how it was able to give you the improvements. And then finally, at the end of it, like there was some to and fro happening, and then finally it was able to generate the result. So yeah, so here I'll show you the result here. So basically, we were trying to, yeah, I can show you the code. Yeah, let me quickly show the code generated. So basically, it was trying to connect to a database and like trying to generate a query, like a graph. So this is the database which it is generating. So it's a cars database. And then we are trying to get a visualization that tells the relationship between the weight and the horsepower. And finally, this is the file which got generated, the scatter plot. You can see the horsepower and the weight. And also the code got generated for that. So, so yeah, this is, and yeah, this I already spoke about the snowflake flavor. So again, here we use the same NLSQL table query engine, but then there is some level of extra, you can say, connection which you need to do, this being a Snowflake database. So this is actually provided by Airbyte example, which I've used here. And finally, like with these examples, I'm sure you got a context of how you can use and generate your charts. So I would like to conclude by showing you this quick demo of our solution Ikai, where we have tried to implement the logic where we are connecting to the database or making API calls and generating the charts. So the user asks to generate a pie chart to show the count of articles based on the distribution of publication. And you can see that the chart is generated. So here we are making, for this specific use case, we have made use of LLM to help us with some part of the code generation also. And this is based on Flutter. So the next question is to generate a bar chart with the same problem statement. So you can see the bar chart is getting generated here. The next one we tried was a line chart, and this is for a different set of tables. So it is for the sales of electronics over the past 3 months. So generating a line chart. So basically from the like the text, it is able to extract the intent. What is the chart we are trying to extract or build, and what is the data we are trying to like get. And accordingly, it will make the call and get the schema, generate the query, or make an API call as may be applicable, and then generate the return the data in the format. So this is the final one, the scatter plot showing the various stock prices. And so this is all dummy data, but I'm sure that this has given a view of how you can actually leverage this LLM ecosystem augmented with LangChain and Llama Index, and then like connecting to your specific data and bring in the real-time insights for your users. So with that, I'll take a pause here and would like we'll look at the questions.
Yeah, Abhilasha, I think we were wanting to answer some of these questions live. So I don't think there's too many. I think there's about 3 questions that were related to getting access to the notebook.
Okay.
Do we have an example notebook we can share?
Yeah, we can share with the recording. Or
Okay.
when we upload it on the YouTube video, we'll add that as part of the details.
Great.
Yeah. So, yeah, there's a question. If Llama Index itself can generate SQL query. So Llama Index is only like a framework which is allowing you to provide the right data to the LLM to generate the query. But it is not really generating the query. For the query generation, you would need a language model to power that, because it is like a dynamic text generation based on the context which you want to generate. So that is where your LLM will become useful. Are there any limitations of LangChain and Llama Index? So I would say like LangChain and Llama Index both are very good frameworks. Both are evolving and continuously like bringing in new things. With respect to this, the current use case also, if you have a very complicated, say, ecosystem or database or data warehouse, you may have to get into that feedback loop and maybe do a multiple iterations till you get that accuracy. But I would say there is no specific limitation from LangChain and Llama Index perspective which limits you. It actually augments you, like helps you to use the LLM in the right way. So in this context, and in general also, I would say these frameworks are really very helpful in making use of LLMs in the real applications, and it gives you a proper structure. So if you directly use the API call versus if you're going through this structure, it helps and it covers most of the things which you would have to manually handle if you're using the APIs directly. So that is the advantage, I would say. I really cannot think of any limitation. How LangChain and Llama Index are secured enough to use within organizations? Will it bring any security threat, just like attack through Log4j? So the security part of it, when you're actually implementing it in your application, when you're connecting to your databases, you have to make sure that you're taking care of the necessary authentication and authorization. And through Llama Index also, when you're definitely at every point, it enables you to give your API keys. You have to give your user ID, passwords if you're connecting to your databases, if you're connecting to your document stores. So that security layer or the authentication layer is there. And if you are apprehensive of using it as an ecosystem being controlled by a third party, then you may opt out of it. It's actually not necessary to use it. It is, as I said, it just makes it more structured and easier. So if you have a really sensitive data which you really don't want to expose, so in fact using LangChain and Llama Index, these are only libraries, so you can still use it. But something like Langsmith, if you're using it, so Langsmith is used for evaluation, which is a part of or an extension of LangChain. So there you would like to be careful and not use the public hosted Langsmith ecosystem. And you can have your open, so you can have your own self-hosted instance also. So as such, these are libraries which are just you can plug and use in your code. So there is no security threat, and you have to use the proper security authentication and authorizations. So that takes care of that. Main challenges what are the main challenges in developing a reliable text-to-SQL system? So definitely the correctness of the query in the overall ecosystem. So you can, and as I spoke in my webinar, the different mechanisms provided to ensure you bring in the feedback, you bring in the autogen agent, or the different flavors of control in order to ensure the correctness of the query. And use the appropriate tools. Like if you have a large database, you would want to maybe index it and then use only query it first and then use only the relevant schema. So those kind of things you will have to make sure in order to avoid any roadblocks in your implementation. So in case we have structural and non-structural data, do you have any use case on that? Like Netflix, we can have details on episode, in structural data and script as a text column for that episode. Yeah, so in the current webinar, I've not covered the example, but I have mentioned one of the constructs which one of the query chains, the SQL join query chain, if I remember correctly the name. So that is one thing which enables you to connect your structured data with your non-structural data and bring in the augmented value. So you can build your response using those two aspects of the data. So, but yeah, in detail, maybe we can plan a different webinar for that. Sometimes agent didn't able to resolve the error, are not able to solve the error during the execution. So how to handle this? Yeah, very valid question, and we are facing this in like wherever we are using LLM. So as Scott also mentioned, so accuracy is a problem sometimes, and that is where we bring in some you can say custom logic and some extra control. So like how we have handled this, like I can talk about a few ways. So one is like you can have like a retry loop. You do a custom like a custom logic to check the correctness of your syntax, and then like retry your LLM call or the agent call. So so that you're not like letting the error thing go outside of this loop, right? So an extra custom layer or an extra custom layer to correct it also. So if it is something which can be corrected, where you can have some control, so you can bring in that as well. Like for example, I can give like when we were generating some code and we saw some duplicate methods getting generated in spite of giving instructions to the agent. So we fixed it through a custom logic after the code is generated to like comment out the duplicate code. So these are different ways we can work around it, and definitely like prompts is one important way. Like try out with the different prompts. Autogen is one very good example. See what is working for you best so that you can reduce your errors and improve your responses. Can you please suggest what steps we can follow to make sure the query generated is an optimized one? So optimization is again, that is something you would have to give some examples and some extra instructions to the large language model to be able to like make sense of that. And specifically this problem will come wherein you have like a huge database and multiple joins involved. So some kind of basic instructions where you join on the ID fields and those kind of things you can do. Also, you can have the control on the database layer itself, where you can add the required indexes so that your query is more optimized that way also. So the plans are better and the execution is faster. So it has to be thought through and implemented on a case-by-case basis. But then if I have to speak generically, definitely it has to come as a additional instruction, and maybe some examples of some historically, if you have seen some queries not performing well, so you can give those examples of avoid these kind of joins and avoid these kind of select queries. So that can be a good way to instruct the model. How can we use semantic filter in your structural data? Yeah, semantic filter, if you're referring to the semantic layer, yeah, I mean, in this case, when you're using an LLM and if you're directly interacting with your database, so your semantic layer is more of the control. When you're requesting for your LLM, you're giving the right content, and when you're getting the response, you're filtering out the right response. So that is one way of how you can bring in the semantic filtering. The other way could be the text to API approach, where you actually generate your API, which will bring in the semantics and connect to your database and get the data depending on your different filtering conditions. Yeah, if we have a lot of tables, is there any agent which populates schema and helps LLM to pick right tables and columns? Yeah. So yeah, so one way to achieve. So there is I mentioned this briefly. So there is a like a query chain provided by Llama Index, which gives you the capability. Or I'm sorry if I'm yeah, I think it is Llama Index or LangChain, one of them, where actually you can control the schema which you want to send. So if you have a lot of tables, you would not want to send all the schema. So the first layer of the query will actually query your schema and find the relevant tables, and then only send those tables to your actual LLM query. So that is more of like, you can use a vector database also and have that metadata structure to be able to rightly identify which are the tables you want to pick. So again, that would be a design decision of how you want to structure your schema, because either you put it in a document and you let the model just pick whatever is most relevant first and then use it for your next query generation, or you can put it in a vector database and do a query search, get the data, get the schema information, and then pass it on to your LLM. So yeah, so hope that answers the question.
Thank you, Abhilasha. Thank you, Scott. And you have shared really valuable insights with us. And thank you to everyone who has joined us today. I really hope everyone found this session very informative. So, and before we conclude for today, I would also like to mention that we have another exciting webinar, which is scheduled in 2 weeks. That is on October 19. We will have an insightful discussion on how we can maximize synergy with autonomous agents using retrieval augmented generations with large language models. So I will be sending out invitations to all of you. Until next time, everyone, and thank you once again for being a part of our webinar today. Have a good day, everyone.